The planet is straining under the effects of climate change. Many researchers believe we have to intervene to prevent the worst from happening.
To many people, it might sound a bit like playing God.
Manipulating oceans, seeding clouds, creating a sunshade for the Earth out of sulfur. These are just some of the ideas.
You can't tackle something of this scale, this scope, moving this fast with just science.
Modifying our climate, is it hubris? In Iceland, researchers have already turned greenhouse gases into stone.
And then you can see sort of white spots, and that's what the CO2 we injected into the pilot reservoir.
That's a solution to our climate problem.
Definitely, in my opinion, this should be one of the solutions that we apply at a large scale.
Scientists want to interfere with the Earth's processes. Can geoengineering save us? Not just by getting harmful CO2 out of the atmosphere, but also by cooling our planet. We're on our way to meet some researchers pursuing radical ideas.
I'm worried that climate change has become a kind of political abstraction, and people have lost track of the drive to protect the environment they love.
David Keith of Harvard University is one of the most controversial climate researchers. He believes it's high time we had an emergency plan. His idea is to create a sort of screen using dust particles, which would reflect the sun's rays, weakening or even halting global warming.
So you're just here for 2 days?
But the first big pilot project, named SCOPEX, keeps being postponed. There's still too much opposition.
What it is it's something that might, in combination with emissions cuts, reduce the overall climate risk, maybe substantially. That's the evidence we have from climate models. So the question is, to what extent could solar geoengineering reduce climate risks that actually harm people and the environment, like extreme storms, extreme temperatures, sea level rise? Those are research questions that we don't know the answer to.
So-called solar radiation management is a gamble. Little research has been done on the risks, and yet it could be a last lifeline when it comes to curbing global warming. In practice, it would mean at least 10,000 aircraft injecting the stratosphere every 2 years. The planes would release sulfur particles as evenly as possible at altitudes of more than 10 kilometers. These particles would reflect 1 or 2% of the incoming sunlight. The fact that dust in the stratosphere cools the planet has been shown by powerful volcanic eruptions, such as Pinatubo in the Philippines in 1991. At that time, the global temperature dropped by 0.4 degrees.
How much do you have to put in there?
Well, it depends how much solar geoengineering we want. So there's no right answer to that. But the quantity would be measured in something like 1 million tons a year.
Is that a lot?
Well, it's a lot and not a lot. We're putting billions of tons a year of CO2 in the atmosphere. So one of the ways to think about it is there's a 1,000,000-to-1 ratio between the amount of warming power of CO2 in the atmosphere and the amount of kind of cooling power of, say, sulfuric acid or some other material in the stratosphere. So 1 million tons is not technologically a lot. It doesn't cost a lot. But it's a real direct perturbation to the environment.
Doesn't that tell us also that the stratosphere is just a place you should not interfere because it's so sensitive?
You're speaking as if the alternative is non-interference. But the CO2 is already in the atmosphere. Even if we cut emissions to 0 tomorrow, which is basically impossible, but even if we cut emissions very quickly, which we could do, that doesn't make the climate problem go away.
And humanity is a long way from zero emissions. Once we started pouring sulfur into the stratosphere, the sun shade would have to be replaced regularly. Otherwise, temperatures could rise to levels even higher than they would be without the manipulation. The technology has its skeptics.
My biggest fear is that climate change will advance to the point where this planet can no longer sustain human life.
Climate activist Drew J. fears that solar geoengineering will change weather and precipitation patterns, damage the ozone layer, and produce more acid rain. Some studies show such risks. For Drew, geoengineering is worse than climate change itself, and even researching the methods is dangerous.
Governments are watching this closely, oil companies are watching this closely, the military is watching this closely. So there's a political experiment that's happening that says, you know, what if we could go this route? And you're opening up a pathway, and the further you go down that pathway, and the more you make it seem real. So an experiment is research, but it's also political theater.
Yeah, but you will never stop people from thinking and from searching for ideas and solutions. So the idea of geoengineering is already in the world, so you can't stop that.
You can't stop the idea of geoengineering from existing, but what you can stop is it being considered a good idea.
Many people, including me, have talked about how unequal solar geoengineering is, how it would help one place and hurt another. But actually, in climate models, when we put an even amount of solar geoengineering in, it seems like really every major region in the world has their climate risks reduced.
Experimentation with this leads to a planetary-wide experiment. You have one planet, and you're risking the whole planet to do that experiment.
For sure, solar geoengineering has risks, but not doing solar geoengineering also has risks.
While we're increasingly aware of the effects of climate change, we can't accurately predict the consequences of geoengineering. We're on our way to visit an environmental activist who's committed to strengthening nature's own capacity for self-healing.
Do you know what my biggest fear is? It's that the history of the collapse of civilizations is really repetitive. And we're seeing the tail end of one of the most expansive civilizations in human history.
In remote South America, Chris Tompkins and her husband, Doug, have given vast areas of land back to nature. Together with the governments of Chile and Argentina, they created 13 national parks, an area the size of Switzerland. The first was Patagonia Park. Since the death of her husband, Chris Tompkins lives here alone. She's told us to come right on into the house and to please take our shoes off.
Hello.
Hello, Kristine.
Welcome.
Nice place at the end of the world.
Yeah.
Kristine Tompkins was head of the outdoor clothing company Patagonia. Her husband had founded the brands Esprit and North Face. In the 1990s, they left the business world and went on to invest around $350 million in nature conservation.
I don't believe that technology is some sort of techno-fix that will fix all the technology that got us here in the first place. Look, if I thought that was even remotely possible, in the short term, I would say, great. And then I really do say, well, then why are you showing up so late? Because the party started a long time ago.
Is there a way to turn it back?
There are no messiahs when it comes to this. You can't tackle something of this scale, this scope, moving this fast with just science.
Edward Wilson said we should give, I think, half of the
Earth.
Earth
Yeah.
back to nature. In the size and the scale you do it, can that make an ecological difference?
You can enter these places and you understand what is, was, could be. And that's an enormous, enormous contribution. I have begun to see the value in things or measure the value of things more by their absence.
Chris Tompkins laments the destruction and inequality in the world. In her mind, entire regions should be protected from humans, and especially from the clutches of the globalized economy. Can that save us from climate catastrophe? Probably not, but maybe there's more to it than that. It's about spaces where natural systems can regenerate, where we can save the things that represent life on this planet.
We believe that all life has intrinsic value. The non-human world is struggling, and much of the human world is struggling. So we see the health of all life on the planet going in the wrong direction, and have done for the last 30 years, let's say.
They call this age the age of the Anthropocene. And it is, and I'm not interested in that. I don't believe that gets us where we want to go as humans and for the non-human world in the long term, not even in the short term.
What does that mean for our approach to fighting climate change? Is it better to leave things alone, or to intervene and try to limit warming, to give plants and animals in their present climactic zones a chance? In Davos, a meteorologist is investigating another way of cooling the Earth.
One of my biggest fears about climate change is that water supplies will become even more unequal, more droughts, more floods, and especially in terms of more droughts, that there'll be more climate refugees and more wars fought because of climate.
Ulrike Lohmann thinks it's possible to manipulate cloud formation in such a way that global temperatures fall. The likeliest candidates seem to be cirrus clouds.
Cirrus clouds have a greenhouse effect. They hold more heat radiation in the Earth's atmosphere than they reflect sunlight. It's the only type of cloud that we know has a warming effect.
Cirrus are thin streaks of ice cloud that form many kilometers above the Earth's surface.
Theoretically, if you got rid of all cirrus clouds, you'd cancel out the doubling in CO2 levels.
Clouds have a big influence on climate and temperature. The lower ones cool the Earth. They should definitely stay. But cirrus clouds have a warming effect. They form when ice nuclei are present in the air, like when an airplane's turbines condense water vapor. Cirrus clouds form naturally in cold, humid conditions. Although they do reflect some sunlight back into space, they only allow some of the thermal radiation from the Earth to escape. So, on balance, they heat us up. In order to cool the planet, cirrus clouds would be prevented from forming. Likely parts of the atmosphere could be seeded with desert dust, for example. The ice nuclei would grow faster, become larger, and fall to Earth as hail. The radiation balance would change, and the temperature would drop a little.
The advantage of Sahara dust would be that we know it wouldn't do too much to the ecosystem. It would have no side effects. But when it comes to testing this method out, a small-scale test would get lost amid the noise of natural variability of the clouds. You would really have to do something on a very large scale to see if it worked. I'm not sure that that would be possible politically, because who would make the decisions? Which bodies would decide? Which individual country would do something like this?
And in any case, who would benefit from it? In order to answer that question, Ulrike Lohmann wants to learn a lot more about cloud formation. This measuring device attached to a balloon uses a laser to examine individual cloud particles. It's not clear that thinning out cirrus clouds in Central Europe would have an overall benefit. And if the seeding was done incorrectly, it might cause even more cirrus to form. But perhaps this method of halting warming would be effective in the far north.
It would definitely make sense to seed Arctic cirrus clouds, especially in the winter, because we have no sunlight during the winter months. So it would really just be cancelling out their warming effects. And yes, we want to preserve the Arctic sea ice, of course. But there are economic interests in the Arctic being navigable. So who wins out?
Manipulating the warming cirrus clouds is still theory, but making thunderclouds rain down in order to prevent damage from hail has long been practice in Germany. So-called hail flyers like Holger Miconi show that weather isn't just a question of fate.
So what's in there, Holger?
You've got the liquid, an acetone solution with 3% silver iodide. You've got a pump and a valve, controlled from inside. Behind is a combustion chamber. And there's an atomizer nozzle where the mixture ignites.
These days, people across the world manipulate the weather. China has a huge government agency that sends rockets into the clouds. How and whether the silver iodide works hasn't been conclusively proven. It probably creates smaller ice crystals, which become rain more quickly. Since large-scale hail damage in the area around Donau-Eschingen in 2006, there have been no more instances in the region.
Because of turbulence, the plane gets pulled upwards and also pushed downwards. That can cause stalling. You have to make sure the structure doesn't get overloaded, that the clouds don't pull you into areas where you aren't in control anymore.
Holger Miconi flies where other pilots wouldn't. He tries to spread the silver iodide into updrafts. That way it can rise and get distributed into the cloud from above. In one sense, climate is nothing but the sum of weather events. To change the climate, weather has to be manipulated on a large scale and permanently. Hail flyers only aim to influence weather on a local level.
What we're doing isn't exactly geoengineering. It's more like protection. We're trying to change the material state from solid to liquid. In that sense, the impact on the atmosphere is relatively small. But in general, I don't think it's a good idea to interfere with the weather globally.
Why not?
You're letting a genie out of the bottle, and it could have its revenge if things change to the point where people can't control it anymore. I don't think anyone wants to experience that.
People will probably be prepared to take bigger and bigger risks as the effects of climate change worsen. Glaciers are melting everywhere, like the Aletsch here in the Swiss Alps. The mountains are crumbling.
When I think of the climate and global warming, I also think of all these steep mountains, where rockfalls and landslides can happen. I worry about the people who live there.
Switzerland is one of the European countries most affected by climate change.
Rendezvous on a glacier.
Yes.
Hugo Raetzo has been observing the Aletsch for a long time. Over the last 6 to 8 years, the glacier melt has again accelerated enormously.
The glacier's terminus has receded 3 kilometers since 1870. Now it loses an average of 50 or 60 meters of length a year, sometimes 100.
So how many years until it's completely gone?
Based on models, I think in 80 years it'll be a long way up, so really tiny.
Doesn't it make your heart bleed?
It hurts to think of a glacier like this, which is huge and very beautiful, and picture it being gone.
The melting glacier isn't just an aesthetic problem. The mountain we're on, the Morsflur, has started to move. An incredible 150 million cubic meters of rock has begun to slide. Since 2012, it's happening faster and faster. Cracks are forming dozens of meters deep. The entire mountain could come down on the glacier. before humans began warming the world, the Aletsch was about 400 meters thicker.
400 meters of ice gives about 30 bars of pressure. So that 30 bar pushed against the mountain. Because that pressure's now gone, as the glaciers melted, the mountain is sliding down to the glacier's terminus. It's just sliding away.
Unimaginable forces.
It's almost 2 kilometers wide and 1.3 kilometers long, and everything is moving. That's unbelievably big.
Hugo Raetzo listens to the mountain using geophones. GPS devices measure the displacement, while satellites observe with radar. Even if the great catastrophe can't be stopped, the Swiss want to be prepared when the mountain collapses. They spend 250 million Swiss francs a year on securing their mountains.
For us, as specialists, what's happening is extremely striking, because you rarely see it. It's unbelievable that new fractures are occurring not only in existing weak areas, but also right across the gneiss, the hard stone.
Nature is telling us something, saying, don't turn the heat up anymore. Right?
Right, like we're being shown how it'll be if we keep on like this, yeah.
Getting the genie back into the bottle is no easy thing. In Peru, researchers are asking how the oceans might help us avert a climate catastrophe.
The ocean is such a fascinating and beautiful habitat. I worry that my grandchildren won't be able to experience it in its beauty, in all its richness.
For marine researcher Ulf Riebesell, the plan isn't to cool Earth by reducing sunlight, but to mitigate the greenhouse effect itself. He wants to influence the oceans in such a way that they absorb greenhouse gases from the atmosphere and so reduce the very thing that causes temperatures to rise.
I'm excited about the idea. To many people, it might sound a bit like playing God. But after all, we change so much on land. We're wildly active and don't think twice about land clearing here or creating another man-made ecosystem there. But when it comes to the sea, we find it hard to say why we shouldn't make sensible changes.
The oceans are already a gigantic CO2 reservoir, 50 times larger than the atmosphere. They already absorb a quarter of our greenhouse gases. Is that the limit of the ocean's potential? Or is it possible to make them do a little more? Ulf Riebesell heads an international research group of 60 scientists and technicians. They want to understand how climate change is affecting the special current system off Peru.
They are roughly the same size as Geos are, so they can live in parallel.
The best thing we can do now is to really tap these options and not wait any longer. Because in 10 years, we're going to have to start employing them. In 10 years, we'll have to begin climate engineering measures, these so-called negative emission technologies, somehow getting CO2 from the atmosphere and storing it somewhere else. Otherwise, we're not going to achieve the climate targets set in Paris.
Ulf Riebesell's idea is to artificially create a system like the natural one caused by the Humboldt current here off Peru, which ensures rich algae growth. Fish and other marine animals benefit too.
It's an incredibly productive system here. Nutrient-rich water from the depths is brought up through what's called upwelling. That creates a lot of phytoplankton growth, leading to a very efficient food chain.
Could it be replicated as a kind of global air conditioning system? To access the deep water, hoses up to 100 meters long would be lowered into the sea. The cold, nutrition-rich water would be pumped upwards. Floating wind turbines could provide the required energy. When it reaches the surface, The deep water would cool the air, but above all, it would fertilize the upper layer of water. Plankton would begin to grow, absorbing CO2 from the air. And when it died, it would take the greenhouse gas with it into the depths.
There's already a lot of upwelling here. But the question is, could we do it in regions that are completely unproductive today? We call them oceanic deserts. They're not dry, but they're nutrient poor, so nothing grows. They make up a good 50% of the oceans, these so-called deserts. The idea we're looking into is this. If you artificially create upwelling there, you could absorb more CO2, and you could also boost the fishing yield.
There would have to be thousands of these systems in the oceans to make a real difference. In Lima's military port, Ulf Riebesell shows us his experimental setups. The aim of his research is to better understand marine food chains. He calls the floating racks mesocosms. This is what artificial systems for the upwelling of deep water would look like.
Technically speaking, it's possible. The question is whether we want to do it. But the potential of the oceans is huge. The supply of nutrients in the ocean depths is virtually inexhaustible.
Ulf Riebesell hopes that a significant portion of human-made greenhouse gases could be absorbed into the oceans in this way. His experiments have already yielded an important finding. In order to absorb more CO2 than is transported upwards from the deep water, the pumps in the hose systems should be repeatedly switched on and off. This technique would achieve a fourfold increase in the CO2 uptake of the oceans in these areas. As a positive side effect, fish populations would also be stimulated. But nothing stays on the seabed forever. It would be a case of buying time. Time we desperately need. So far, governments haven't engaged with the topic of geoengineering. There are important questions to be answered, like who would decide what measures to pursue? Who would pay? Is the UN the right institution?
So what I'm worried about is that my granddaughter, who is just 2 months old, she will live to the end of the century, and I don't want her to live in a world where somebody else decides to spray into the stratosphere and cool the planet without asking her.
Janos Pasztor lives on Lake Geneva. He was the right-hand man to UN Secretary-General Ban Ki-moon. Now he heads a non-governmental initiative fighting to increase the political awareness of geoengineering.
Scientific, technical, engineering issues related to these new technologies are sometimes quite challenging, but the governance issues are even more challenging. Yeah. This is part of the culture of managing climate risks, that we have to think about. We need all options probably, and we need more, and we need them sooner, because we are in trouble.
If individual nations manipulated solar radiation on their own, Janos Pasztor's fear is that it could unbalance the climate in other countries.
What is a plausible scenario is that a country that is very badly affected by climate change, for example, a group of small island countries, they'll fix it. They decide to do it. And solar radiation modification is, at least at direct costs, scientists tell us, is not that expensive. So a medium-sized country could do it. A wealthy individual could do it, save the world.
It could be done by a major nation today, yes.
Which brings in problems, right?
Of course, yes. Yeah. But that's true of all sorts of things. So there are lots of things in this world that could be done unilaterally today that aren't done.
Is David Keith going to look people in the eye and say, the U.S. government, will do this unilaterally, but it will be fair to the whole world? I don't think that's a realistic scenario.
Being able to take advantage of the weather is something that of course gives a nation an advantage if they can do it. I think it's already being done today, because the moment you seed clouds to make it rain, then the water that might have been bound for a neighboring country is gone.
You have a company that can go, in the same way that arms dealers go around the world and say, well, if you want to be safe, buy our technology.
Such unilateral efforts could jeopardize the climate of a neighboring country. Although the Intergovernmental Panel on Climate Change has warned of the risks, it doesn't rule out geoengineering as a last resort. Here's something the Intergovernmental Panel on Climate Change says must happen in order to prevent global temperatures from rising century after century. All CO2 that humanity has released into the atmosphere by burning fossil fuels has to be removed. We've come to Iceland to find out how. In Iceland's largest geothermal power plant, it's already being achieved on a small scale.
What I'm most afraid of when it comes to climate change is that we will have a large global refugee problem that will turn nations against each other.
This is where Swiss firm Climeworks tests its technology.
It's like a vacuum. We suck it in here. The CO2 sort of sticks to a surface of a specific chemical that's in this unit there. And then we get the CO2-free air out on this side.
So it all comes through here and it lowers it from 400 parts per million to
less than 100, than 100, yeah.
Okay. That's really hard. I mean, the concentration of CO2 is very little in the air, but still too high.
Yeah, it's very little, which makes direct air capture a bigger technological challenge than capturing CO2 from point sources.
CO2 filters all work in a similar way. There's nothing new about Climeworks' technology. The chemical processes are based on amines, derivatives of ammonia that combined with CO2. When the amine mats are full, they're heated, then they release the CO2 for final storage. The process is repeated thousands of times. But the method, called carbon capture, is very energy intensive. Each ton of CO2 filtered from the air requires 2,500 kilowatt-hours of energy, a huge amount. So it only makes sense in places with lots of excess renewable energy or waste heat, like here in Iceland, with its infinite geothermal energy.
Can you imagine an Earth where we have hundreds of thousands of these machines?
Yeah, I can.
You can?
I can, yeah. I can imagine such a world where we strategically locate those units where we have the favorable geological conditions for CCS. It has to make sense, of course, but I mean, again, we have to think big and we have to act big if we are to be successful in mitigating climate change.
That won't be cheap. Each ton of CO2 filtered by Climeworks costs about €500. And what then? Where do we put it? The researchers in Iceland have found a spectacular answer with the CarbFix experiment. The first step is to dissolve the CO2 in warm water, like soda.
So we inject down to 1 to 2 kilometer depth, and on top of that sits 800 meters of groundwater, meaning that we have very high pressure, much higher pressure than in here, needed to keep everything dissolved.
So that means there's more or less there's a lid on top of it, so it can't escape anymore.
Yeah, and then we have the very exciting chemistry happening as well, because very quickly the CO2 interacts with the basalts. So in less than 2 years, it's turned into a new type of rock. And once it's rock, it's just rock. It's not going anywhere.
Basalt contains lots of calcium, magnesium, and iron. these minerals react with the greenhouse gas.
The theoretical storage capacity of basalts on Earth are a minimum an order of magnitude larger than CO2 that we would emit if we would burn all fossil fuel available on Earth.
Which we hope will never happen. So far, just 12,000 tons of CO2 per year are buried here. To make a difference, the number would have to be in the billions. Concern for the state of the Earth is what's driving scientists and conservationists like Tompkins. But her approach to preserving the beauty of nature could hardly be more different. She wants swathes of nature to be restored as much as possible to the way they were before human intervention.
So when we bought this ranch, all of the Wanako were forced into the high grounds because this was all used for grazing livestock. So this was a big fight between ranchers and conservationists. It still is in Argentina. That ranchers see Wanakos as competitors and they want to get rid of them.
Yeah.
Everywhere around the world there's this inherent conflict between conservation and development. So it happens almost everywhere, really.
The Patagonia Park shows what challenges have to be overcome to turn back the clock and save what could still be saved. 600 kilometers of fences had to be removed, 30,000 sheep sold, roads dismantled, and trees planted. It took more than 10 years just for the grasses to return. Bringing back native animals has proven to be difficult. There's now been success with the endangered Andean deer. Pumas are also back. Other species have to be bred back into the area. Here on the Argentinian border of the park, birds native only to South America are being raised. Nandus. They had completely disappeared from this area. The creatures are flightless. Their feathers are there only to warm them through the chilly Patagonian winter. 60 Nandus have already been released into the wild. The plan is for a population of 100. It requires huge effort to retrieve what was once lost.
The impacts of climate change, the loss of top predators, and how that is a cascading effect over all habitat, and how it affects human well-being as well. All those things, it's not something that's going to happen in the future. It's happening now. You know, a lot of people don't believe that's true, but them not believing it doesn't make it any less true.
Are we going to survive, actually? If you look at that process we've been to the Earth, the damage?
I don't think that's the question. I think that's a very anthropocentric question. Are we going to survive? I don't think all of us will. Why is that? Why are we doing this?
Yeah.
That's the question. And all the answers, at the moment anyway, lead me to think that we're willing to risk everything so that we can have a second refrigerator, or I don't know, you know. And that's why people, young people and old people, are in the streets. Because how dare you, as Greta says from time to time.
And Tompkins herself is no exception. If the younger generation isn't to end up being forced into using geoengineering, then climate protection efforts must increase dramatically. And yet the very prospect of technical solutions could stymie efforts to curb CO2 emissions.
It's a certainty that some people who want to fight against emissions cuts, like big oil or fossil-rich nations, may exploit the work we're doing, exaggerating how well this works falsely, to, with lies, claim that we don't need to cut emissions. That's, of course, complete nonsense. We do have to cut emissions, but I don't think the fact that people will politically exploit this a little bit is a reason that we should, hear no evil, see no evil, and try and pretend there's nothing here.
I haven't given up hope that we'll turn things around in time. And if we do, I think it would be responsible to do some geoengineering for a time, just to flatten this peak of warming a little bit. I'd say temporary solar radiation management, because removing CO2 from the atmosphere will have to be done over a long time. All the CO2 we've emitted has to be taken out of the atmosphere.
The term geoengineering is a misnomer. We'll never understand it in terms of going in there like engineers. We have to feel our way and learn as we go. And we'll have to be able to stop at any time without it coming back to bite us. That's a basic requirement. I'll only consider such measures if we know for sure we can stop without negative consequences.
The science is unambiguous. Existing measures aren't enough to keep the climate stable. So it's probably only a matter of time until radical geoengineering comes into play.
How we act in the next few years, it's really sort of a tipping point on how things might turn out. If we are ready to drastically change our way of living and reduce emissions, put a lot of effort and money into the solutions that are available, but we need to apply them at a huge scale. Yeah. And if we do that, we will be successful.
To destroy beauty, to destroy wholeness, will come around to haunt us, which is, of course, what's happened, whether it's climate change or the breakdown of social structures and so on. So, yeah, I think there is a wholeness, a goodness that rests in all of us. And if we're paying attention, we should start swimming back the other direction.